everyone! My name is Joyce B. Domingo from BSE 3 Mathematics. For today's video, I will be going to teach you the basic differentiation rules, which consist of the different differentiation formulas.
Let us first define what is derivative. Derivative in mathematics is the rate of change of a function with respect to a variable. Derivatives are fundamental to the solution of problems in calculus and differential equations. First is the derivative of a constant. The derivative of a constant is 0. A constant remains constant irrespective of any change to any variable in the function. A constant is always a constant, and it is independent of any other values existing in a particular equation.
What is the derivative of y is equal to 2? Since 2 is a constant, its derivative is equal to 0. In symbols, y prime is equal to 0. Next, find the derivative of the constant function f of x is equal to 10. The first derivative of the constant function f of x equals 10 is f prime of x is equal to 0, since 10 is still a constant number. Next example, what is the derivative of f of x is equal to pi? Since pi is equal to 3.14, it is still a constant number. Then, its derivative is still equal to 0. In symbols, f prime of x is equal to 0.
Next is the derivative of power x raised to n. The derivative of the nth power of a function is equal to n times the product of the n minus 1 power of the function and the derivative of the function.
First example, let's find y is equal to x raised to 5. First step is to move the exponent in front. So it will become 5x, then the exponent less to 1. So y prime is equal to 5x raised to 4. How if there is a numerical coefficient like this, 2x raised to 5? It will become 2 times the exponent 5, then x 5 raised to 1. So it will become 10x raised to 4. Next example, how if y is equal to x raised to 1/2? It will become, like the first example, let's move in front the exponent. So it will become 1/2x raised to 1/2 the exponent less to 1. It will become 1/2x raised to negative 1/2. Then next, it becomes 1/2 times 1 over square root of x. Then the final answer is 1 over 2 square root of x. The last example for the derivative of power x raised to n is y is equal to 1 over x raised to 5. In this case, if there is a denominator like this, the exponent will become negative. So it will become x raised to negative 5. Then, negative 5 times x raised to negative 5 minus 1. It will become negative 5x raised to negative 5 minus 1 is equal to negative 6. So, it is the final answer.
Derivative of a sum. The derivative of the sum of two functions is equal to the sum of their derivatives.
Example for the derivative of a sum. For instance, y is equal to 2x raised to 2 less 4x raised to 3 less 5x raised to 5. Let's just apply the derivative of power x raised to n for each term. Let us first focus on the first term. So let's move the exponent in front or beside the numerical coefficient and variable. So it will become 2 times 2 times x raised to 2 less 1 minus 4 times 3 times x raised to 3 minus 1. And for the third term, 5 times 5 x times x raised to 5 minus 1. So let's just simplify. Y is equal to 2 times 2 is equal to 4. Then simplify this, x raised to 1. Or let's just simply put x, disregard the exponent to 1, less 4 times 3 is equal to 12. Then x raised to 3 minus 1 is x raised to 2 less 5 times 5 is 25. Then x raised to 5 minus 1 is 4. For the better answer, let's just rearrange the answer from the highest exponent to the least. So, it will become negative 25 x raised to 4 minus 12 x raised to 2 plus 4x. So, it will be the final answer.
Fourth is the derivative of a product. The derivative of the product of two functions is equal to the first function times the derivative of the second plus the second function times the derivative of the first.
Example for the derivative of a product. Y is equal to x squared plus 2 times x cubed minus 5. So first step, let's just write the formula of the two functions. First function times the derivative of the second function plus the second function times the derivative of the first function. Next, let's just copy the first function, x squared plus 2, then get the derivative of the second function, which is, let's just focus for the first term, x cubed. So it means 3x raised to 2 since 3 minus 1. Then, since 5 is a constant number, then it is equal to 0. So disregard. Plus, copy the first function, x cubed minus 5. Then, get the derivative of the second function. So, x squared is equal to 2x raised to 1 since 2 minus 1 is 1. Then, since 2 is a constant number, then it is equal to 0. So, let's just simplify. Is equal to, we will simplify using distributive property. So 3x squared times x squared is 3x to the fourth plus 3x squared times 2 is 6x squared plus 2x times x cubed is 2x to the fourth less 2x times negative 5 is negative 10x. Then to simplify, just combine like terms. Since 3x to the fourth and 2x to the fourth, 3x to the fourth plus 2x to the fourth, combine these terms, then followed by 6x squared minus 10x. So let's just simplify. Is equal to 3x to the fourth plus 2x is equal to 5x to the fourth. Then let's just copy the last two terms, plus 6x squared minus 10x. So this is our final answer.
Next is the derivative of a quotient. The derivative of a quotient of two functions is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator.
The derivative of a quotient, let's just follow this pattern. D or denominator times the prime of numerator less the numerator times the prime or derivative of the denominator over the squared of denominator. For example, y is equal to x squared plus 1 over 5x squared. So let's just follow the pattern. First, the denominator, which is 5x squared, times the derivative of the numerator, which is x squared plus 1, less the numerator, x squared plus 1, times the derivative of the denominator, which is 5x squared, over the square of the denominator, which is 5x squared to the power of 2. So 5x squared, then find the derivative of x squared plus 1, which is 2x. Since 1 is a constant number, let's just disregard this. Less x squared plus 1, then the derivative of 5x squared, which is 2 times 5, then x raised to 1, or let's just say it's x, over 5x squared raised to 2. So let's just simplify. 5x squared times 2x is 10x to the third, less, simplify the 2 times 5 times x, which is 10x. So 10x times x squared is 10x to the third, plus 10x times 1 is 10x, over 5x squared to the second power. Since 10x cubed and negative 10x cubed has the same power, then let's just cancel. So our final answer will be 10x over 5x squared to the second power.
Next is the chain rule.
For the chain rule, let us follow the formula. Y is equal to f of g of x that has the derivative given by y prime is equal to f prime of g of x g prime of x. For example, y is equal to 2x plus 5 raised to 3. Let us first identify the outer and the inner function. The inner function is 2x plus 5. Inner function. While the outer function will be x to the cube. Let us first define the derivative of the inner function or the g of x, which is the 2x plus 5. So g prime of x is equal to the derivative of 2x is 2. Then, since 5 is a constant number and its derivative is equal to 0, it is equal to 2 because the exponent 1 times the numerical coefficient 2. So, it is equal to 2. Then, let us define the derivative of the f of x, which is x cubed. The derivative of x cubed will be x prime of x is equal to, move the exponent in front, 3x, then the exponent less 1. So, f of x will be equal to 3x squared. 2, 3, go. Stop mo! Let us find the f prime of g of x, wherein we will be using 3x squared. Then let us substitute x by this equation, which is our inner function. So it will be f prime of 2x plus 5 is equal to, raised to, mali! So it is equal to, let's just follow the equation, 3, then the value of x will be 2x plus 5. So 3 times 2x plus 5 raised to 2. Then solve the equation. The last step, we will now use the formula y prime of x is equal to f prime of g of x, g prime of x. So, h prime of x is equal to our f prime of g of x is this. So, 3 times 2x plus 5 raised to 2. Then, our g prime of x, this is equal to 2. So, let's just simplify this equation. Multiply 3 by 2. So, h prime of x is equal to 3 times 2 is equal to 6 times the quantity of 2x plus 5 raised to 2. So, that is the chain rule.
Last is the power of a function rule.
For the power of a function rule, if n is a real number and y is equal to g of x raised to n, then dy over dx is equal to n, the quantity of g of x raised to n minus 1 times g prime of x. So, to better understand, let us have an example. So, for instance, f of x is equal to x squared plus 5x plus 3 raised to 4. So, first step, let us find the f prime of x follow this formula, our n will be the exponent 4 times the g of x raised to n minus 1, which is our equation x squared plus 5x plus 3. Then, our n minus 1 is 4 less 1. 4 minus 1 times the g prime of x. So, let us define find the derivative of this equation. So, it will be 2x plus the derivative of 5x is 5. Then, since 3 is a constant number, then disregard. So, just 2x plus 5. The derivative of x squared and 5x and 3. So, f prime of x is equal to 4x squared plus 5x plus 3 raised to 4 minus 1 is 3 times 2x plus 5. Our final answer is f prime. So our final answer will be f prime of x is equal to 4 and the quantity of 2x plus 5, then this x squared plus 5x plus 3 raised to 3. So this is our final answer. That explains the power of a function rule in this case.